Hello. This video is going to talk a little bit about the basics of motion graphing. Basically, motion graphing is a way to use graphs to represent the way an object moves. Motion graphs are a type of line graphs, which means they basically consist of the same three parts. This is the horizontal axis. In motion graphs, this axis is almost always the time axis. This shows how much time has passed since we started counting. This is important to how motion graphs work. We start counting and then we look at how the object moves at each second. The vertical axis is normally the variable we're interested in. It can represent position, velocity, or acceleration. Position is usually represented by the variable x. The zero spot is a special area on the motion graph. It is usually called the origin. The origin represents where we start measuring and counting. In this case, we have selected the orb's resting place to start measuring. The displacement refers to how far the waker has gone from the origin, and this is counted against time. The last part of the graph is the data, the particular values we're graphing. Here it is represented by the green line. The data line describes what value the vertical variable takes at a certain time. It links the data on the two axes. To make things easier, graphs sometimes have tick marks which help you pick out which values line up. On a graph labeled like this, the horizontal tick marks represent seconds. Usually each one is 1 second, but sometimes they represent a larger value like 5 or 10 seconds. The other axis is labeled x. That means it represents the position of an object. Usually this is measured in meters. Let's say we have an object and we want to observe its motion. This object could be anywhere and move wherever it wants. So how do we keep track of how far it has traveled? The answer is we set an origin, represented here by the mark of a red tape. We also measure off a distance in equal units, here 3 meters. Now, no matter how far the object moves, we know where it has traveled. It's like it's moving on a number line. We'll return to this idea when we look at an example. V on this graph stands for velocity. Velocity is a lot like speed, only velocity includes direction, like north or south. Velocity has units that are distance per time. You probably already know how cars measure velocity in miles per hour. The amount of distance the car would cover if it moved at the same speed for a full hour. For example, if a car is moving at 60 miles per hour, it will travel 60 miles in 1 hour if it stays at that speed. Usually, since we use meters, we'll talk about meters per second. Velocity can be measured in other units, but it is always some distance over some time, because that is the definition. You can have something traveling at 5 meters per second, like a person running, or maybe you have an inchworm moving at 3 inches per second, or you lob a ball at 20 feet per second. Now here we see acceleration. You notice the seconds on the units now have a funky 2 up there. We would pronounce this as meters per second square. Just like how velocity measures how position is changing, how many meters something moves in a second, acceleration describes how velocity is changing, how many meters per second something is getting faster. We'll look at these objects to learn what acceleration means. The top one moves at a constant speed, which means zero acceleration because it isn't getting any faster or slower. The second object, with an acceleration over 0, moves differently. It accelerates after it starts moving. Notice how it gets faster and faster. Watch both of them together to see the difference. Note that this is different from velocity in that an object with a velocity of 0 would stand still, while an object with an acceleration of 0 moves forward with a constant velocity. So now we'll try to figure out exactly what a motion graph tells us by looking at an example graph. Here is our graph with position, time, and our data line. What this graph is showing us, as time goes on, the object is moving further to the right and farther away from where it started. Let's take this step by step to figure out exactly what this means. When we start counting, the object is at the origin. After 2 seconds, the data line is telling us that our object is at the 1 meter mark. Look how the number line changed. Our object moved 1 meter. The blue lines show how we got the information off the graph. We can see that the green data line lines up the 2 second mark and the 1 meter spot. At 4 seconds, we see our object is now at the 2 meter mark. And by 6 seconds, our object has moved a total of 3 meters. So our object seems to be moving 1 meter every 2 seconds. Saying it that way makes us realize that we now know that speed must be half meters per second, because that is the distance traveled per every second. Now we can take a look at another important aspect every line graph has, and this is called slope. At each point in a line graph, the data line has a slope. A graph has a slope no matter what it's describing, which means our position graph also has a slope. The slope is a number that describes how steep or shallow the line is. On a position graph, slope corresponds to velocity. The bigger the slope, the steeper the line, and the smaller the slope, the shallower the line. So if we change the lines like this, we see that the line is now steeper. This means that a line has a bigger slope. An object that traveled at this velocity would move farther at any given time than an object moving at this velocity. This line has a smaller slope and therefore velocity, because the line is shallower. Slopes can also be negative. This line goes down from right to left, so it has a negative slope. This means that the velocity is negative too, so the object is moving backwards. Horizontal lines are a special case. A horizontal line doesn't go up or down, so the slope here is 0. This object would just be sitting 2 meters away from the origin with no velocity. Another important point about slope is that a line has a slope no matter where it is. A slope has nothing to do with where you find the line, only how steep or shallow it is. So all of these lines have the same slope even though they are at different points in the graph. Let's go back to the position graph we examined earlier. We can go directly from the position graph, the x graph, to the velocity graph, the v graph, by looking at the slope. So we put a mark at 1 meter per second on the velocity graph. If we do this for all of the points on the position graph, we can see that the velocity graph forms a line. Since the slope is the same everywhere on this graph, the velocity of the object is the same. This makes sense. No matter what time it was, the object was covering 1 meter every second. Thanks for watching. If you have any questions, feel free to rewind and go over the material.